All right, here's the homework 5.6, the integration by parts homework. In this one, there are 9 questions, so not quite as much repetition necessary, hopefully, as the U substitution stuff. It's good to get some reps on this stuff, but they're also kind of tedious and they can take a little while, so I just didn't want to drive you crazy with this stuff. First question, look at this. This should be about as straightforward as integration by parts gets. Look at the 2 different things being multiplied together and figure out which one should be U. And another way to figure that out is ask yourself the question, if I'm going to have to take the integral of something and that something will contain the derivative of u, which of the things do I want to be u? Which one gets significantly easier when I take its derivative? What's the derivative of e to the negative 6x power? Yeah, that's no simpler. What's the derivative of x? Oh, that's really simple. Hopefully this one will go fairly straightforward for people. And actually, same logic goes for number 2 here. There's no reason you can't take this 4 and factor it out in front of the integral and then decide which should be u, and then the remaining stuff will be your dv. Down here, it's a little bit harder. First off, the variable changed to z in my version of this problem, although they might cycle through different letters. But don't let that trip you up. Just pretend it's an x. You can take the 9 out in front of the integral, but I think what you'll see is the fact that this is squared, my variable is squared, might mean that I have to use integration by parts 2 different times instead of just 1. So more tedious than hard. Be really careful with your parentheses when you do this one. Number 4 here, it might not look like, depending on your version of the problem, something times something, but remember dividing by z to the 13th power, for example, is the same as multiplying by z to the negative 13th power. So maybe you can rewrite this as a product, and maybe that'll help you determine how to integrate it using integration by parts. In other words, what u should be equal to. Then we get to question 5, the only one where it's a definite integral, and really the only reason there is because definite integrals are tedious, and I don't want you to have to do too many of them, but I figure you should get practice on one of them. So there's exactly one on the homework with the definite integral. It's this one. The way you do integration by parts is not all that different than what you will have done on a previous problem. So I think if question 4 goes okay, maybe question 5 will go okay as well. You'll just have the extra steps of plugging in the 1s and the 5s at the end. And then when you get to questions 6, 7, and 8, they're a little bit tricky. In fact, all of these come from what I refer to as the trick problems. This is really similar to one of the examples that I did in the trick videos, and then these 2 are similar to the other example that I did. So the example that I did where we figured out the antiderivative of natural log of x, that technique will work very similarly for questions 7 and 8. And then there was a video where I figured out, I think it was e to the 5x maybe times the sine of x. I can't exactly remember what the constants were in there, but the method that we used on that one is very similar to the method you'll use on this one. So if you don't immediately know how to do 6, 7, and 8, maybe double check those videos. And for question 9, okay, it's the extra credit problem, so don't stress about it a whole lot, but if you want to try it, I think you can figure this out. The big place where a lot of students will get stuck is an algebraic step. Right, so start out by doing integration by parts, makes sense, it's the integration by parts homework, and see where you get. And I think at one point in your process, you might end up here. You might end up having to figure out the antiderivative of x squared over 1 plus x squared. If you solve this the way I did anyways, you'll get to this step. And the algebraic trick that I want to show you is we could always put like a 1 plus x squared minus 1 over 1 plus x squared if we wanted to, right? X squared is the same as 1 plus x squared minus 1 because 1 and minus 1 just cancel each other out. And you're like, yeah, I guess that's true, but why in the world would you do that? Well, now I have a difference of 2 things, right? I have a difference of 1 plus x squared and 1. So this minus this over 1 plus x squared, I could rewrite that as 1 plus x squared over 1 plus x squared minus 1 over 1 plus x squared. Right, kind of thinking about this as grouped together. The parentheses aren't doing anything there. They're just trying to illustrate a point. That allows me to rewrite this quotient as the difference in these 2 quotients. And the advantage here is this is just something divided by itself. So what I'm saying is I get 1 over 1 minus 1 plus x squared. And I think this might be really hard to integrate, whereas this might be a lot easier to integrate. But to get from here to here, it's a pretty clever algebra, and I didn't want you to struggle forever on that, so I wanted to give you that little hint.